Hello and welcome to Unit 3, Part 5. My name is Mr. Bell. We're going to talk about translating or shifting and transformations of quadratic functions. This slide says to describe the transformation from the parent function f of x equals x squared. And I'll draw a little rough graph of that one down here at the bottom. So we have our coordinate plane. The parent function of y equals x squared, or f of x equals x squared, is sort of like the basic quadratic function that makes a parabolic or a U shape right kind of in the middle of the graph. And you can test this by graphing on your calculator, and I'll show you how in person. What we're going to do, we're going to look at these examples, and depending on what I do to the parent function, it's going to determine what happens, which way it shifts. Does it shift left or right, or up or down? Does it get wider, or does it get narrower? Or does it reflect across or does it do a reflection transformation? So we're going to take a look at several different examples to try to figure out what the patterns are. Well, if you take a look at number 1 here, it says f of x equals x squared plus 3. Well, if we add or subtract a number on the outside, like away from the x squared, that's a shift up or down, and it's the same as what it looks. Since this says plus 3, I'm going to do it in green. That means I'm going to take my parent function that's in blue here, and I'm going to shift that graph up 3 units. Okay, so I would describe this as up 3 units. I'll do number 2 in yellow. This one, if you noticed, inside where the squared is, not outside of the parentheses, but inside, it says x plus 5 and then squared. The inside is a left or right shift, and this one's kind of tricky. It's the opposite of what you think. So a plus 5 actually means a shift to the left 5 units. And how it would look if you tested it in the calculator would be from the blue parent function here. It would be a shift 1, 2, 3, 4, shift to the left 5 units, but have the same general shape. On this slide, we have 2 more examples. Number 3 says f of x equals negative x squared. Notice how I've drawn my parent function in blue. When there's a negative in front, it implies a reflection, okay? And I'll do it in green. So I'm going to take the parent function, the one in blue, and I'm simply going to reflect it the other direction. Okay, so I would describe this as a reflection. Take a look at number 4. It says 1/4 x squared. Your coefficient of your x squared terms determines whether your function is going to get narrower or wider. And a lot of times it just takes typing this in the calculator, graphing it, and seeing what it looks like to figure out which one it is. If I have 1/4 x squared, anytime you have a number less than 1 in front of the x squared, your graph is going to actually get wider. It's not a shift left or right or up or down, but it is a dilation factor. In this case, it gets wider. Number 5 says f of x equals 5x squared. Again, I have the parent function of a quadratic y equals x squared graphed in blue. Notice how the coefficient here is a number greater than 1. In this case, the 5 is telling me that I'm going to take my original parent function and make it narrower. Okay? Narrower, or more narrow would be another way to say it. Take a look at number 6. In this case, you're going to do more than one transformation. Okay? If you notice inside the parentheses, it has a -2, and remember when it's beside the x like this, it's a left and right shift opposite of what you would think. So in this case, it's a -2. That means I'm going to shift to the right 2 places, but I also have the +3 on the outside, which implies, remember the same that it looks, a vertical, a upward shift of 3. So not only did this particular function slide to the right 2 places, but it also slid up 3. On this last example, we're given an initial function, and we're asked to create one after performing this transformation. So let's take a look at what our final result would look like. So we have f of x. Okay. To begin with, we should be able to notice at this point after the previous examples that this one is shifted actually to the right 3 places. So I'll use right 3, and it shifted up 4. That's where we started at, was a right 3 shift and an up 4. Well, now this is telling me that I need to shift up 3 more places from when I started. So in that case, I'm going to add 3 more to the up direction, giving me a new position of up 7. Left 1 is tricky. If I want to go left 1 from where I've started at, remember the left and right shifts are opposite of what you think. So left 1, instead of subtracting 1, I'm actually going to have to add 1. So from this minus 3 that I started with, I've got to add 1, so my new right position is negative 3 plus 1, which is a negative 2. So the function would look like this: x minus 2 squared plus 7. This describes moving my initial function, which didn't start at the parent function. That's tricky. We started here. At the 4 position, I needed to move up 3 more. My new position is up 7. I started at a shifted to the right 3 positions, but if I want to move it to the left 1, this needs to say minus 2. So now it is only shifted to the right 2 places instead of to the right 3 places, which is actually meets the transformation requirement of to the left 1. I know this one will take some practice, but once we do a few of them, you'll get better at it. All right, thank you for watching and hope this helps.